Alright, welcome back everyone to another video, and in this one we have the VoCore2. Now I've featured this board in some of my previous videos, and then I suddenly sort of stopped featuring it, and today we are looking into solving that. Um, so just kind of an overview, it's a very small board. Now it looks like a square, but it's actually a cuboid, so it has peripherals on all the four sides as well as below. I'll go more once we are able to remove these wires, and that is why we are here. Um, so what happens that this board has a QSP flash for its main operating system storage. It has an SD card, but it doesn't directly boot from an SD card. We can chain load stuff from the QSP flash, but for the most part, the router or the OpenWRT operating system stays in the QSPI flash, which is like a 16 megabyte flash, which is enough for a Linux platform that runs just routery stuff. So this is basically like a MediaTek bought. I think it was Link. MediaTek bought them, and this is one of the chips rebranded to MediaTek. And it's a MIPS processor. That's why I'm extremely interested in it. This is the only MIPS processor development board that I have, and I intend to keep this one alive. And due to a mishap last time when I was trying to flash it from like within its bootloader using Uboot, it didn't flash properly, and that ended up in completely breaking it, and it just won't boot. So to solve that, I brought in a QSPI flash programmer. Now you could use another similar device, another VoCore2, another something else. I think even a Raspberry Pi 2 should do. But I just wanted to kind of buy a proper bias flasher or SPI flasher, and I bought that. So it was pretty cheap. Here it is. It is the CH341A. I'll move this to one side. And this is the chip flasher. We have the SPI links coming on from here. You can also put your chips on there, and there are some chips that use UART. Those goes here. But we are using SPI for now because most of them do use SPI. There is a program called Flash ROM that is available in the Linux, in many Linux distros, and that seems to work just fine. So for most of today's videos, the flasher would be like separate, doesn't really show you anything specific. Again, once we have all of this removed, we'll go back and take a look at both the flasher and the board itself once again. But for now, what we need to do is take a small jumper and make sure that the board stays in reset mode, and for that we'll short two pins, which is uh, pin number 3 here, and then pin number 7 there, and that should keep the board in reset mode and not allow it to boot, so that we can go ahead and flash it properly. It's a very thin wire. I don't think you guys can see it that well, but there's a wire there. And we have 3.3 volts coming in here, and then ground, clock, chip select, clock, MOSI, and MISO. And let's flash it. So over to our main screen, I have connected the CH341A programmer, and hopefully this doesn't fall off. And with that hope, let's go ahead and take a look at our terminal. So let's try to read the contents of our flash chip just as a test, and then we'll go ahead and add other stuff to it. And reflash everything. So if I press enter, they should start to read the content and give you the chip ID as well. All right, so it has detected two chips. Actually, it's confused between B and C variant, but I know that this is a B variant chip. So all I have to do is add the chip ID itself, and I think we should be good to go from there. And let's see. So now it is reading the flash contents, and it will save it in backup.txt. We might look at it later, but it won't be too interesting. There might be some things there that I can show you of how flash ROM backup looks like. But for now, we are kind of just uh, reading from the flash. Alright, so the reading is done and it only took a few minutes surprisingly. If you flash or read the SPI flash from within the chip or from within the U-boot or Linux booted up, that takes more time probably because the clocks are much slower and the flasher is providing a very high clock. So that could be a reason. But let's go ahead and flash our original firmware. So I have downloaded it off of VoCore's website, and you can get yours too. So I'll just issue the command and we'll take a look how that goes. And here we go. So again, pretty much the similar output. This time it will first read the whole chip, make sure there are no, I don't know why it does the whole reading part, just to, I guess, verify the length. And then it will erase the whole chip with zeros. And after that, it will flash the new image. So we'll get to see everything in action. Of course, this takes a while, so I'll skip all of it. Alright, so the write has been verified, so that means we are safe to unplug everything and the flash has been written. So let's go ahead and do that. I have unplugged the flasher itself and we'll take a look at it, remove the jumper and then carefully remove all of these wires. So the reason I didn't go for directly soldering it to the board, soldering pins to the board and then adding it, and I did all of the thin wire to the clips, and all of that work, is that there was a clear warning that you might want to use a temperature control soldering iron because too much heat would bake the chip due to static, and that does happen. And also the proximity to the chip is pretty close. Usually on dev boards you have a large area and then you can like add all your wires wherever you want. No one's stopping you to solder stuff on. But alright, so this is the VoCore2. That's our MIPS chip, around, I even don't remember the clock speed, but it has 128 megabytes of RAM, 16 megabytes of SPI flash. We have an audio DAC. We have a 10100 network. The chips are right there for those things. We have a USB port and we have an SD card as well as a micro USB for UART. So a very very packed dev board, really tiny as well. And here's a bit more closer look. So it is the, nope, I can't still read the chip number. I'm probably you guys can. There you go. And give you guys a bit more closer look on the board itself. So VoCore.io for all those interested. This is a pretty old product to be honest, but there's still some community support, and it's in upstream Linux kernel, so that's good. And here is the flasher itself. I will remove these wires. So yeah, so this is the CH341A chip. It is basically just an interface between USB to a couple of, or actually four different interfaces. So you have parallel printer port, you have UART, you have I2C, and you have SPI. And this one just uses, I think, UART, SPI, and I2C for various ROM chips. So you have 25 SPI bias, 24 I2C EEPROM, and you have the SPI and UART ports broken out, which is why I was able to use this. this is an extremely cheap piece of kit, and you can actually get for a couple of dollars, maybe more like $5 or $6 if you're reasonable. But you can get these really cheap. It runs at 3.3 volts, so this is a 3.3 volt level shifter here, or not a level shifter but a regulator, linear voltage regulator. Yeah, so this is what made it all possible. Kind of, I could have used a Arduino or something, but you have your lever. You get a PCB as well, so you can have your chips on that PCB and then put that chip over the whole socket thing and flash it. So I'm planning to do a couple more videos with this one. You will see in the coming days. Maybe I'll flash a bias or two, and we'll see how that goes. But for now, let's plug this in and see what happens. All right, plugging this in, and let's go ahead on our main system and press enter. So you can see the boot log, and it has started to boot. It's actually already booting the Linux kernel, uh, and it usually boots U-boot first, but since we are powering it at like using the same USB port, it boots pretty early. So we skipped the U-boot, but if you want to see the U-boot interface, we can always soft reset it once it is powered up, and we'll go through like the whole like what's inside this and all of that stuff. So there it is, and if I go and run uname a, the default firmware still runs the vendor kernel 3.18, which is pretty old, and I am looking to upgrade it pretty soon. So we will see that as well. And then, and yes, CPU info reveals the processor name, which is MediaTek MT7628AN, which is a rebranded Rawlink processor. We have MIPS 24K EC version 5.5 at around 385 BOGO MIPS. And we don't have the frequency, sadly. Of course, you can see it in the spec sheet, but yeah, so that's about it. It supports MIPS 1, MIPS 2, MIPS 32R1, and MIPS 32R2, as well as MIPS 16 and some DSP functions. Apart from that, that's about it. I will explore this board later, and for now, thank you so much for watching, and I will see you all in the next one.